Hi students, this is Mr. Yao. Today we are going to learn about 1.3, which is on how to factor greatest common factor. But before we do that, let's do a problem that is related to what we have learned in the previous lesson. If I ask you to multiply this, or in other words, distribute, you should be able to do that. You just need to multiply the 18x squared by the 3x. That's going to give you 54x squared. And 18x squared times 1 is another 18x squared. Now, I'm going to ask you to try to think backwards. In other words, pretend that I did not give you this top equation, this top expression. I only gave you the bottom. The question is, how can we get back to the previous one? You can pause here and kind of think through. After some thinking, maybe here are your thoughts. Oh, I actually had one mistake. This first thing should actually be a cube. Okay, now let's think. How can we get back? Or in other words, how can we take out 18x squared? The x portion might actually be easy for you to think about. Well, the first one has 3 of them. The second one has 2 of them. X squared is like the most amount that you can take out. You can take out x squared. Some of you might be, wait, what if you just take away an x? Well, if you take away an x from x cubed, you still have x squared. And if you take away x from x squared, you still have an x. So that's not the most amount you can take. Some of you might be, what if we take 3 away? Well, if you take 3 away from x cubed, you don't have any left. But if you take away 3 from x squared, you actually go to x to the negative first power. In the previous lessons, we have learned if you have negative exponents, that's not even a polynomial anymore. So we can't do that, which is why the most amount of x that you can take away from x cubed and x squared is just x squared. The next thing would be, well, how did we get 18? If you notice, these two numbers, 54 and 18 is divisible by 18, and 54 is also divisible by 18. That's why we take out an 18. And even if you didn't do 18, you did it little by little. Let's say you could take away a 9 from 54, you're left with a 6 and a 2. Then you take away another 2, which means you will be taking away 18. So that's what we got in the front. Well, if you took away x squared from x cubed, you are left with an x. And if you took away 18 from 54, you are going to have a 3 left. And from the back, if you take away x squared from x squared, you just have a 1. And if you take away 18 from 18, that's also just a 1. And that's how we got it back. So this is the basic idea of today's lesson. Now let's define a few more things. In the previous lesson, we learned that is called multiplication or distribution. In today's lesson, this process is called factoring. And they are inverse operations of each other. That is the main point of this lesson. So, factor. Any term that divides into a given term evenly without remainder. You actually have done factors before. You did factor tree. So for example, 12, and you took it apart, 2, 6, then 2, 3. Well, 2 is a factor, 2 is a factor, 3 is a factor, because they can divide into 12 evenly. And they are factors. Then we have something called greatest common monomial factor, or in short, GCF. Starting from this lesson, all the rest of this unit, we are always going to refer to that as GCF. Greatest means largest. Common means things that they share. Factor, well, things that can divide evenly into 2 or more terms. That means you're trying to take away as much as you can from all the given terms and see what's left. That is the process of factoring. Now let's have a look at a few examples. Here, example 1. We are going to find some greatest common factors from all of these. First, for 24 and 36, you might notice, oh, they can both be divisible by 12. So I'm going to just divide by 12. 12 must be the GCF. That is true, but let's say you don't know 12 is the GCF. You may have noticed they're both even numbers, so you decide to just go small steps. 2. 2 is a factor, and this is kind of a little setup. You can put the factors on the left side, and then you're dividing by the factor. 24 divided by 2, you have 12. 36 divided by 2, you have 18. And then you are taking more away from the 12 and the 18. So they're both even again. I can take away another 2. Then we have a 6 and a 9 left. And they both can be divided by 3. So I'm taking away 3. 6 divided by 3 is a 2. 9 divided by 3 is a 3. Well, now between the 2 and the 3, we can't do any more. So in that case, the factors that we have divided are 2 and 2 and 3. That is why the GCF is all of them together. So 2 times 2 times 3, which is 12. Again, you can surely go for 12 right away, or you can go these smaller steps. And you also don't have to go, say, 2, 2, 3. Let's say the first step you notice, oh, maybe they're divided by 6. Then you have a 4 and a 6 left. And between the 4 and the 6, you could take away another 2. Then you have a 2 and 3. In that case, you still get the same thing. 2 and a 6 multiplied together is also going to give you 12. So that's like little steps to find the greatest common factor. B, x to the 4th and x cubed. We're finding the greatest thing that they share. When you have 4x's and 3x's, of course they at least share 3x's, which means they share x cubed. That is your GCF. See, that is the example I gave you at the very beginning. For all the x's, they share x squared. Then for 18 and 54, same thing. Let's say you didn't notice they're both going to be divided by 18. Let's say you only noticed they're both going to be divided by 6. Okay, then you have a 3 and a 9 left. Then you take away another 3. You have a 1 and a 3 left. The 1 and the 3, they do not share anything, which is why the GCF for the numbers is 3 times 6, which is 18. So the GCF is going to be 18x squared. So this is the process of finding the GCF. Now let's actually use the GCF to factor. Here we go. Step 1, you are going to find the GCF of the coefficients and the variables separately. And that's exactly what we did. For the variables, we found it's going to be x squared. For the numbers, we found it's going to be 18. So the GCF is 18x squared. After we found the GCF, second step, follow the setup on the right, put the GCF outside the parentheses. It is 18x squared. But here's the thing, when you factor that out, you still have things left. Let's be very clear, factoring is the inverse operation of distribution. Distribution is multiplication, which in other words, factoring is kind of like dividing, which is why the step 3, ask yourself what would be left if you divide each term by the GCF. So we are actually dividing by 18x squared for both of the terms. 54 divided by 18 is a 3. X cubed divided by x squared is an x. 18 divided by 18 is a 1. X squared divided by x squared, well, it's also a 1. So you don't have another number, it's just a 1. Something I do want to emphasize on, if you see them being the same, you might be like, well, I'm taking it away. So doesn't that mean I shouldn't have anything left? The answer is no. It's just like when you divide 5 over 5, that's a 1. You still have a 1 left. And if you don't have that anymore, think about if you try to distribute and try to get the previous equation back, where you won't get it. Step 4, rewrite so that you have a monomial multiplied by a polynomial. In this case, that's already what we have. Sometimes you might want to put into standard form. That's about the only thing. So now let's practice. Example 2, the GCF for 42 and 48. Let's go small steps. Maybe you have noticed they're both divisible by a 2. Then you have a 21 and a 24 left. Then they're both going to be divided by a 3. You have a 7 and 8 left. So you can't take any more. 2 times 3, the GCF is 6. Example 3. First, let's look at the variables. X to the 4th and x squared, they share x squared. 21 and 9. If you take away a 3, you have a 7 and a 3 left. And they do not share anything else, which is why the GCF for the numbers is just a 3, and altogether the GCF is 3x squared. That is example 3. Moving on, example 4, 2a plus 6b minus 8c. If you look at each term, always check the variables first. First one is an a, second one is a b, third one is a c. They do not share any variables, so you can't take away variables. The factor now, we need to consider numbers. We have a 2, 6, and a -8. In this case, they're all even, so we can actually take away a 2. That, in other words, means you're dividing every single term by 2. So we have an a left in the front. 6 divided by 2 is a 3b. Negative 8 divided by 2 is a minus 4c. And that is the result after factoring. Let me write on the side, my GCF is a 2. Example 5, GCF. Same thing, let's identify that first. X cubed, x squared, and x, this is actually x to the first power, they at least share an x. And then for the numbers, 20, 15, 5, they at least share a 5. So the GCF is 5x. Let's take that outside, which also means we're dividing every single term by 5x. So 20 x cubed divided by 5x. 20 divided by 5 is a 4. X cubed divided by x to the first power, that is x squared. Second one, 15 divided by 5 is a 3. X squared divided by x to the first power, or in other words, take away 1x, you still have an x left. Lastly, 5x over 5x, that is a 1. Again, make sure you have that extra term. Otherwise, think about it. If you distribute, you only will get 2 terms back, but you started with 3. So you have to have that plus 1. It's almost like a placeholder. Just know you do have something there to multiply back. Example 6. Same thing. Let's look at the GCF. Variables. The first one has x squared. Second one has an x. Third one does not even have an x. So we can't take out any x's. Y, y, and y squared. So at least they have a y. Now the numbers. 14, 7, and 28. That means they share a 7. So let's take out the 7y. And then you have, so negative 14 divided by 7 is a negative 2. X squared, well, you didn't take any x away, so that stays. For the y, you took away a y, you don't have any left. Or in other words, you have a 1 left. But that's already multiplied with a negative 2x squared, so still doesn't change anything. Next, negative 7 divided by 7 is a negative 1. You still have an x left. Then y, take away y, you do not have any y's left. Plus 28 over 7 is a 4. And then you still have the y squared, take away a y. You still have a y left. Now, there is something very important and a bit special for this. Something to remind you. A lot of time when we do distribution, we always say the sign in the front of the number is actually together with the number. If that is together with the number, in other words, the first number is negative 14, second number is negative 7, third number is 28, they actually have not just a 7 as the GCF, it's actually a negative 7. So here we go. You're supposed to take out a negative, which means that will be flipped. This will change into a plus. The last one will also change into a minus. So the final answer is negative 7y is a positive 2x squared plus x minus 4y. That's example 6. So let me emphasize on that again. Whenever you see a negative sign in the very front, you need to take it out. You need to consider that to be part of the factor. Or in other words, in your final answer, we always want the first term inside the parentheses to start with a positive sign. Okay, now let's do the same thing for example 7. We start with a negative, so at least we know that has to be part of the GCF. X's. First one has x cubed, second one has x squared, so we can at least take away x squared. First one has a y, second one is y squared, so we can take away a y. First one has a z, second one has a z, so we can also factor out a z. 16 and 4, they share 4. That would be my GCF. So let me copy that in the front. Negative 4 x squared y z. Let's see what's left. So in other words, we're dividing by negative 4x squared yz. Negative 16 divided by negative 4 is a positive 4. X cubed divided by x squared is an x. Y take away y, nothing left. Z take away z, nothing left. For the back, 4x squared y z. Negative. That would change the sign, so it's 4 divided by negative 4, which is a negative. X squared take away x squared, no x left. Y squared take away y, you have a y left. Z take away z, you do not have any z's left. So final answer right here after we finish factoring. That's example 7. And that is everything for 1.3 factor greatest common factor. Thank you.